Hi everyone, welcome to this video around compass and ruler geometry. Today we are going to look at how to divide a circle in 5 equal parts using only a compass and a ruler and no protractor, for example. So obviously you could divide 360 degrees of a circle by 5 and you'd find 72 degrees and use that to divide the circle. But here we're going to look at the compass and ruler construction. And I'm going to show you 2 different methods. There are more methods to draw a pentagon, but here are 2 methods that really start from a circle and are meant to divide that circle into 5 equal parts. And we are also going to see how from those 2 constructions you can easily divide further in 10 and in 20. It's just as easy as dividing in 5. Those 2 methods are equally valid. Each person has their preferred one. I prefer the second one. You can practice both and find the one you find the most easy to remember or easier to get accurate. Sometimes it's not the same depending on people. And this division in 5 is the basis for a whole range of very cool 5-fold symmetry and 10-fold symmetry motif, which is a really interesting type of geometry. And so my name is Lucy Rose and I teach geometry, compass and ruler geometry, mainly online courses, sometimes in-person courses in England or in France. You can find more details in the description below. And a lot of what I teach is that geometry applied to Gothic architecture motif, but not only, as you are going to see. Oh, and before I forget, I'm at the end of a little cold, so you might hear my voice is a little blocked, but hopefully you can still enjoy the video. So, as I mentioned, I'm going to share 2 different methods to divide a circle in 5, and those 2 methods I learned at the School of Traditional Art when I was doing my MA there. You can also find them in this amazing book by John Allen, Drawing Geometry, which has lots of the basics. So the one we're going to do are this one and this one. There are other methods that can be used to draw a pentagon from a line, for example, but this is really to divide the circle in 5 equal parts. And so I'm going to share the 2 methods, and the first one is maybe the easiest one to remember, but I prefer the other one, so I'm gonna, the next one is the one I use most of the time, but like here we're gonna start by the one that we call the yin-yang ones, kind of. You're going to see why in a second. So first off, I have this A4 format paper. It's landscape here just because it fits nicely with the camera, but you could orientate this any way you like for drawing your circle. Just you need to start with a horizontal line if you want the pentagon to be orientated vertically like the usual way. So first draw a horizontal line in the middle of your page, whatever the format. You could do this smaller, although this is a nice scale to understand this to begin with. And I'm just going to mark the middle of my line to place my circle. You could place this randomly. This is just to make it kind of symmetrical. And I'm going to use a radius of 8 centimeters here, just so that I can see what I'm doing. You could just eyeball any circle that fits on your page, but as a note, I'm using 8 centimeters here. And I'm going to draw my first circle from there. So just the radius of the compass to this measure and draw your circle. Now the next step is here to divide that circle into 6 from the horizontal line. So keep the same exact radius on the compass, and you could have a look at my video about how to divide the circle in 6, and you know that dividing a circle in 6, you can do so by just using its own radius. And I'm going to draw the 2 full curves here, although you could be more minimal with your lines. It's just exactly the same radius as the initial circle. You can know that because you see I'm going through the center of the circle. again when I'm drawing those arcs. So I'm drawing two oval shapes, two vesicopices, or two mandalas, they can be called. And so those points on the circle divide that circle in 6 equal parts. Here we're going to use those two oval shape to draw two vertical lines, like this, from the intersections. And then we're going to use the intersections left and right, which are essentially half radiuses. So that vertical line is cutting this segment in half exactly. So those 2 points are the half radius for the initial circle. And we're going to use those as centers for 2 circles. So compass point on the intersection, adjusting the radius of the compass to the center of the circle, and that will be the same as to tangent the circumference of that circle. And so I can draw a circle that kind of nests here in this mandala, in this almond shape, and that is tangent to the center of the circle and the outer circumference. And I'm going to draw exactly the same thing here. So now I have 2 circles that are tangent to each other and that are tangent to the circle containing them. And this is why this is called the yin-yang method, because this is exactly, I mean, this is not like an official term, but like some people call it the yin-yang method, because that's how you would draw yin-yang, drawing 2 tangent circles. Like you can see here, you just draw only half of each circle and you get a yin-yang shape. But here, I'm going to use this to find my division in 5. And I need one other thing before finding the right measure, and that is a perpendicular line. So the perpendicular line is going to divide the circle in 4 from the horizontal, finding a vertical. So again, here you could have a look at my other video on how to divide the circle in 4 and in 8 and etc. to get more details. But just mainly know that here I'm going to use roughly 3/4 of the diameter from one side of the circle. So here I have my 3/4 is already kind of shown on my drawing, so I could use it exactly, but it doesn't need to be exact, because what matters again is that I'm going to use exactly the same measure from the right here. So I've just marked a little arc up and down from the circle, and then exactly the same measure from the left side, like so, from my horizontal line and the circle. And that's giving me 2 intersections that I can link to draw my perpendicular line, like that. And just as a little side note here, if I was drawing this much bigger, for instance, and if my compass couldn't go bigger than the initial radius of the circle, if like I couldn't go to 3/4 of the diameter, if I just had the radius, then I could also do this step with a smaller radius from each tip of the mandalas here and get a smaller measure. And again, as long as I use the same from both sides, it will fall on the same perpendicular line here. So that would be another way of finding that perpendicular. Right there. So now we have this. We can, we're going to link 2 points. Here, what we are looking for is a tangent arc. And you could adjust the tangent. I'm going to show the arc, in a second. You can always find a tangent by adjusting on the drawing, but it can be a little hard sometimes when you're not used to it. So I'm going to find the exact point to find the right radius by linking my intersection here at the bottom, so my sort of south point, and the center of that circle on the right, like this. You could do it on both sides, but you only really need it on one side. And now the radius I'm using is from my south point again to the intersection between the line and the circle on the right, like that. And drawing an arc, and see how it, oops, here, see how it just tangents our two circles, like that. So that's a different radius than the radius of one of the circles. It's bigger. It's the radius of a circle that has its center here and is tangent to the two tangent circles we had drawn previously. And this here on my compass is 1/10 of the circle. That means that if I link the two intersections of the arc and the circle in a straight line, this line here is already one side of my pentagon, because here I have 1/5 of the circle. I'm gonna show this again. So I mean, not again, but I'm gonna show you how this goes around the circle. So now I want to open my compass to the whole width of that segment, like that here. And I'm going to walk the compass up, or walk the measure up. So from this intersection here of my tangent arc and the circle, I mark the circumference of the circle on the right from here to here. Then the same thing on the left from here to here. And now if I do the same thing from each of those marks, I should fold back on the top here. Now, fivefold is always a little bit tricky to get exactly right the first time, just because there are so many steps involved. So a little mistake here will build up and then will end up like a 2 millimeter difference at the top. So for instance, here I'm ever so slightly above the exact intersection. That's me being picky. This would be totally fine. But just if you want to be extra precise, this is where you'd need to adjust a little bit, make your compass measure a little bit shorter until you get the right intersection here, exactly on the north point. And so in this case, I'm going to mark the intersections that are part of the fivefold division, and I'm not going to do 1, 2, 3, 4, 5. I'm all going to mark them 5, just to say that they're part of the fivefold. It will make sense in the other example why I'm doing that way. So this, it belongs to the 5 fold, this as well, here and here. So that means that I can draw a full pentagon linking those points. Like this. And of course I could draw my 5-pointed star as well from there. And I'm going to do this on a tracing paper just so that it doesn't get too messy. So here, little tracing paper, and I'm going to just tape it lightly. You could totally do this on the same drawing, but sometimes it's nice to be able to lift. Like that. And so my 5-pointed star will link the 5 points in a different way. So on the first, for the pentagon, you link each of the 5 points one to the next around the circle. And here you're skipping one. So from here, I'm skipping the next one and I'm going to the second one. And there's like the only other option of how to link those points anyway. So with a 5-pointed star, there's not much chance of a mistake here, but sometimes with other divisions, when you draw the star, it can get a little more confusing. So I'm just going to go around like that. So just a couple of interesting things here. First of all, you will notice that the star here intersects exactly on this intersection of the arc we had below and the vertical line. So that's an interesting connection. And it makes sense because the curve here is part of the tenfold division because its radius was 1/10, if you remember. I might come back to that. Don't worry if that's... just notice that the intersection here falls here. That's quite nice. And also I'm going to draw here the flower that relates to the 5-pointed star. So previously when I went around the circle, I used this radius here of one side of the pentagon, and I used that to mark the circumference. And I only marked the circumference because if I drew the full arcs, it would be a bit too messy, and then it's harder to adjust the measure if you need to tweak your placement of the 5-fold exactly. But you could, if you did draw in full those arcs, so one full side of the pentagon from each point of the 5-pointed star, or from each angle of the pentagon, you'd get a 5-petal flower. Like that. And you'll note that the intersections of that flower fall on the same point as the intersections of the 5-pointed star, which is quite nice again. So you could draw directly the flower without the 5-pointed star and have the same reference for the inner pentagon of the 5-pointed star, because there's a pentagon inside here which contains this other kind of flower shape or curved 5-pointed star. And the last thing I want to mention about this 5-pointed star is that it's a one thread star, so it's just one shape. It's not two overlapping shapes like an 8-pointed star that would be made of 2 squares, or the 6-pointed star which is made of 2 triangles. Here's just one shape, and so if you go from the top and you just follow the thread like this, it can be traced in one continuous movement without lifting the pen. So that's for our 5-pointer star and the pentagon. Now from here we could also divide in 10 and in 20, but I'm going to show that in the next with the next method. For the second method of dividing the circle into 5, and again I've already drawn a horizontal line, and you could place this whatever orientation of the page you like, but just start with a horizontal line. And we're going to use that other method. I don't know if it has a kind of a name or a nickname, but it's related to the proportion of the golden ratio, and I might do another video later to explain what I mean by that, like how this is using the proportion of the golden ratio to divide in 5. That will be the topic of another video. Just here I'm going to use exactly the same radius for this other circle. You could remeasure with your ruler, that's 8 centimeters, but there we go. It's a new circle. And for this first, going to show this method twice, but for this first version of it, I'm going to draw kind of the arcs in full, like I've done for the other, and then I will show you how I make this more minimal, which you could apply to the other method as well. So first here I'm going to draw the vesica piscis on the right, so the mandola almond shape on the right hand side, but only on the right hand side, not on the left. So this is like maybe of a more asymmetrical method. And I'm also going to use that to find the half radius here. So I'm drawing this vertical line, which is cutting the radius of my original circle in half exactly in this point. And then I'm also going to need the perpendicular vertical line, so the division in 4. You'll note that this is half of a 6-fold division, like I showed in the previous version. And here I want the 4-fold division as well. So dividing in 5 kind of always uses the combination of the 4-fold and the 6-fold. And here I'm using again 3/4 of my diameter approximately, as long as I use exactly the same measure left and right. So from the intersection of the horizontal line and the circle, I make a little arc up and down, and then exactly the same measure on the left hand side, and I'll get those little intersections up and down to get my perpendicular line. Like that. And now from here, I have 2 more steps to divide the circle in 5. I'm first going to use this intersection. So I'm going to write 1, that's like the first of 2 steps, as the center, and the radius will be to the north point here. So compass point here, compass point here, and I adjust my radius to the north point here, and I'm going to bring this measure, so from the center to here, my radius, I keep the compass here, and I will bring this arc down on the horizontal line. So I'm looking for the intersection between this arc and the horizontal line here, okay? So that's step 1, and step 2 is from here as a center, from the north point. So I'm going to write 2 next to it, and then this time the radius will be to the intersection I found on the previous step. So from the north point here, you'll see you need to open the compass a little bit more to reach this last intersection there. And if I draw this arc in full here, that is already 1/5 of the circle on my compass. So I've drawn the arc in full, but then for the next one I'll just mark the circumference. But so 5, I'm doing the same thing as the other one, 5, 5. And just to note that this is the 6-fold mark, not to confuse them. And so I have this same radius on the compass, and from the two intersections, left and right, I'm going to walk the compass down. So I place the compass point on the intersection here on the right, and I mark the circumference on the circle. See, it's close, but not that close from the 6-fold division that we had previously. And exactly the same thing on the other side. Same measure down. And now you have 5 points on the circle, but you do need to check if this is actually exact, because the 5-fold is tricky that way. So to check that this is actually exact, you place the compass point on one of your two intersections at the bottom, and you see if that crosses the other one. So here that is pretty exact, but that might not be the case for you, and it's not always the case for me. I often need to adjust a little bit here, and I'm going to explain that in a second. But first I'm going to mark 5 here and 5 here. So these are my 5 points of the 5-fold division. If I link them, I get the 5-pointed star. So what I mean by adjusting is that here, if the two arcs don't cross exactly on the circle, it means you need to adjust the radius of your compass, but not just on the last step. You need to adjust it from the very beginning. So if your cross here is inside the circle, that will mean your measure is too short. So you'll have to start again from here and make the measure a little bit bigger. It's usually not much. It's an incremental kind of discrepancy, I think that's the word, or error. And it builds up. So just a little bit more here, and you mark the circle again, left and right. And then from that adjusted measure, you mark down again, and then you check again. And if that is exact, then you get your 5-fold. So again, if the cross was inside the circle, then you need to make the initial measure a little bit bigger. And if the cross was outside of the circle, you need to make the initial measure a little bit shorter, and until you get this exact intersection. And the annoying thing that sometimes you end up with like a lot of lines here because you've tried many different radiuses, so you need to try and mark what is the exact one with like a different color or a little dash or something to remember what is the actual point of the 5-fold division. This might seem to be a little bit picky, but when you use this as the starting point for more involved drawing, it's quite important to get this first 5-fold right. It really makes a difference. So that's our 5-fold for this version, and I'm just going to draw the pentagon here, and then I'm going to do this exact process again, but I will do it in a more minimal way so that you see how I usually draw it. You could totally, you can use whatever method you like, but what I like about the method I'm going to show you is that it leaves not too much mark on the circle, and that's interesting for, again, when you're doing this as a first step of a more involved drawing, and you don't want to have too much thing kind of going on that could interfere with the rest of your construction. like so. So that's my pentagon. And I could draw the 5-pointed star, etc. And last note on this, this pink arc here is already the same arc as the 5-petal flower here. So it's just exactly the same arc. If I had done the flower, this arc would be part of it. So that brings me now to the last version of this. So exactly the same method that I've just shown, but in a more minimal way. So the way I usually draw it. And again, let's mark the middle of a horizontal line. I'm going to draw the exact same circle again. Here from the center point. And so again, this time it's the same as the second method I've just shown, but more minimal. So here, instead of drawing the big arc from the right-hand side of the 6-fold division, I'm just marking the circumference of the circle. So if I show you this again, here I had one big arc. So here I'm just marking the intersections on the circle that I actually need to find my half radius. And again here, instead of drawing the full vertical line, I'm just marking the horizontal line here. I'm just marking the half radius because that's the information I need. I don't need the full line. Okay. And I will need the fold division. I will need a perpendicular line to my horizontal. And here I'm also going to use 3/4 of my diameter, like in the previous step. So a little arc up, a little arc down. Same from the other side, like this. And here I am actually going to draw the axis in full because it makes sense with what I'm going to do after. So perpendicular line. So now I have circle divided in 4 and I have a half radius marked on the right hand side. Basically that's what I need to start my 5-fold division steps. And here, just like on the previous version, I place my compass point on the half radius first, and I adjust my compass to the north point, and I mark this measure on the horizontal line. I don't need to draw the full arc like I did previously. I just need to mark the horizontal line here. And sometimes you can think this is a half radius, but it's actually not. You see it's not the same thing. And the last step is from the north point, I need to increase the radius of my compass to now meet the last intersection I found on my horizontal line here. And I just mark this on the circumference of my circle, left and right. And again, this is already 1/5 of my circle. And I'm going to walk that measure down. So from each of those 2 marks, I'm going down on the circumference of the circle. Same on the left. And I check at the end. See here, I'm slightly out. So I'm going to adjust a little bit. I'm starting again at the north point, checking I'm really on the intersection. I'm just using an ever so slightly smaller mark, left and right, and replacing the compass point on the new intersection. And when I end up here, I am pretty much on the circle. So that would be what I'm looking for. So So this is what I mean by adjusting here and actually marking the right intersection. Now I have divided the circle in 5 now, and you see this is a lot more minimal. I have just like the sixfold marked up and down here. I have the mid radius and I have this random intersection here, but it's not too much noise to then be doing lots of other things on that circle. I'm not going to draw the pentagon here because I'm going to use this circle here to show you how to divide further the circle into 10 and 20. So first I'm going to mark these as the being part of my initial 5-fold division of the circle. And you'll see that once you've divided in 5 with that method or with the other method, you already have all the elements to further divide in 10 and 20. So the key element here is that my circle has been previously divided into 4 with those 2 vertical lines. And the north point here is part of my first 5-fold division. So to divide in 10, I'm going to use the other end of that vertical line, the south point here, okay? Because this point is exactly midway between my 2 and my 2 points of the 5-fold division down here. So it's dividing this 1/5 arc in 2, okay? So I'm going to start from here with the same 5-fold measure you've just adjusted at the step before. So this measure on the compass, but this time from the south point. And it's the same, you mark the circle left and right, and then from each of those 2 points you go up this time, you mark the circle again, and on the left here, and then at the top it should intersect nicely because we have adjusted previously. This could be adjusted a little bit more, but it's fine. So now those new points I've marked, I'm going to label them 10 because they make the 10 fold division. I'm going to show that in a second. So 10, we have the south point here as part of it, then those 2 points on either side, and then here. Okay. So first of all, because 10 is an even number, you can now link the opposite points on the circle and get an actual, you can actually see the division of the circle in 10. And the key element to know that you're not linking the wrong intersections would be to go right through the center of the circle every time. So if you're like this, you're way off the center, it's because you've linked to the 6-fold mark that we made at the beginning, but it's not relevant here. So really make sure you're linking the correct opposite points on the circle. Like that. And you kind of have to forget about the horizontal line to really see the 10 equal slices. I could have drawn the symmetry axis in a different color, but I am going to use this horizontal line now to further divide in 20, and you'll see the 20 slices of the cake or of the circle. And I'm not going to draw the stars here. I think I'm going to make a separate video about the stars at some other point. But the idea is that, see, I've started my 5-fold from the north, and then I repeated it from the south to get the 10-fold division. But now my horizontal line is also subdividing this 1/10 of the circle in 2. So if I still use exactly the same radius that I used previously for finding the fivefold. But this time I use it from the intersections of the horizontal line and the circle. So I can do it from the west, from the left-hand side first, and I'm marking it up and down this time. So I'm going in that direction, starting from here, marking up and down, and then from each of those two marks, I carry on, falling here and here. And then you could always double check that it's falling on the circle. So now I have 5 of my segments divided in 2, and I just need to do exactly the same thing from the other end, from the east side, intersection of my horizontal line and the circle on the right. Same measure, but this time I go towards the left. I mark the circle up and down from the right hand side here. And then from each of those 2 marks, you just have to keep them in mind, the same thing further along. And here. And I'm going to label all of those 20. And you'll notice that it doesn't work for 15. It's not like I can add one side and make it 15. It would be uneven. So this method goes from 5 to 10 to 20, basically, using the perpendicular lines of the fourfold division. So what's happening here is that we have a fivefold division, and it's like 5 times 4 from each of those 4 points, and that makes it 20. Hopefully that makes sense. And then you can again link the opposite points on the circle, going through the middle of your circle, and you'd have a circle divided in 20. So that should be even. You could take your compass to measure each little segment, but that's how you can divide a circle in 5, 10, and 20. So I hope those constructions were clear enough, and don't hesitate to tell me in the comments if you have questions. Don't hesitate to tell me your favorite way to divide the circle in 5, if it's one of those 2, or if you have a different one. And hopefully that's made it a little bit clearer, because I know the fivefold division can be tricky to understand and to remember. The best thing is to choose your favorite one and just practice it until you can do it without the instructions. So that makes the rest of the construction a lot easier if that step is already kind of less brain work. And around fivefold and tenfold, I'm also going to say a word about this painting in the background, which I made a few years ago in relation to an exhibition that was happening in a medieval town with stone walls, and which had loads of rose bushes. So this is kind of a geometric rose bush. So the background is a decagonal grid. It's based on decagons and pentagons going around them, and some of them are overlapping. So it's constructed with a ruler and compass as well. And I also designed a small rose motif in a pentagon shape, and so I've placed those roses within the grid and linked them. So this is kind of my geometric rose bush. So that's an example of something that can be more creative in geometry using fivefold and tenfold, and that is not specifically linked to a specific architectural tradition. And also I have an online course coming up in April 2026, so depending when you're watching this video, with the Gentle Penman. So it's going to be an online course on 3 sessions about more creative geometry using the fivefold and the tenfold division. So this is like the basic step for then following that course, even though we are going to come back on how to divide the circle in 5 during the course. So you can check the details. It will be linked in the description below. I also have, before that, at the end of March 2026, so 28, 29 of March, next week, or at the end of this week, depending when this video comes out, an online course on 2 sessions over the weekend around the rose window, the Gothic rose window of Strasbourg Cathedral, which is mainly a 16-fold, so 8, 16 type of symmetry. So you can have a look at my video around 4-fold and 8-fold as a basis. But that rose window also uses 5-fold symmetry in the little sort of ornament flower details, which are called polyfoils or cinquefoils, that we can see around the circle in the petals. So we are going to include some 5-fold division in that course. Again, you can see the details link in the description. And if you want to stay up to date with my online courses and in-person courses, you can follow the link in my description to sign up to my newsletter as well. I also have a monthly live session called the Geometry Café, which is via the Buy Me a Coffee platform. You can find more details below. It's a small subscription and you can unsubscribe anytime and access past recordings. You can also follow me on Instagram for all the geometry stuff. You can follow Lucy Rose Geometry, and for my more artwork, geometry, and not always geometry related, you can follow Lucy Rose Art. Obviously, you can also subscribe to this channel for more videos around geometry, more tutorials, but also interviews of geometry people and hopefully more things to come. Thank you so much for watching this video and hopefully see you next time.